All right, let's talk about the oldest story ever told. And I don't mean a story written in a book. This one is written in light. It's a story about this faint glow that fills the entire universe, a message that's been traveling towards us, since the very beginning of time itself.
Yeah, just take a second to let that sink in. We're not talking about light from some distant star here. This is light from the moment of creation. It's been on this absolutely epic journey for 13.8 billion years. And here's the crazy part. It's not just out there somewhere. It's all around us. It's kind of like a ghost from the past, this incredible relic we call the cosmic microwave background.
So what is this thing, the CMB? Well, put simply, it's the afterglow of the Big Bang. Think of it like the leftover heat from a massive explosion. When our universe first burst into existence. This is that warmth, that leftover glow. It's literally the most ancient light we can possibly see.
Okay, so to really get what this light is telling us, we've got to go way, way back to the very beginning of its incredible journey.
13.8 billion years. Can you even wrap your head around that number? That's how long this light has been traveling. It was created when the universe was just an infant, and for every single moment since, every galaxy forming, every star being born, even the start of life here on Earth, this light has been speeding across space, witnessing it all.
And here's the part that really blows my mind. The CMB isn't just something we point a telescope at out there. It's everywhere. It's here, right now. Photons from the very beginning of time are streaming through the room you're in, through you this very second. We are constantly bathing in this faint, ancient glow of creation. How cool is that?
But this ancient light wasn't always free to just zip across the cosmos. For the first few 100,000 years of its existence, it was basically a prisoner, trapped inside what you could call a cosmic fog.
So imagine a fog so thick you can't even see your own hand in front of your face. Now, multiply that by, a billion. That was the early universe. It was this scorching, hot, incredibly dense soup of particles. Protons, electrons, just chaos. And the light particles, the photons, they were just bouncing around like pinballs, ricocheting off everything, completely unable to travel more than a few inches. The entire universe was basically opaque.
But then, something absolutely incredible happened. The universe hit this crucial turning point, and finally, the light was set free.
And this is the key moment in our whole story. About 380,000 years after the Big Bang, which in cosmic terms is practically no time at all, the universe reached this critical tipping point. It had expanded and cooled down just enough for everything to change.
And this shows you exactly what went down. Before this moment, on the left, you've got that impenetrable glowing fog. The universe is hot, it's dense, and light is just trapped. But then, as it cooled down, something amazing happened. Protons and electrons could finally pair up and form the first real atoms. And that one event, it basically cleared the cosmic fog. All those particles that were trapping the light were now locked up inside atoms. And just like that, for the very first time, the universe became transparent.
Now, the light that burst free back then was incredibly bright, super hot. But as it journeyed through a universe that was constantly expanding, something really interesting happened to it. The very fabric of space itself was stretching, right? And it stretched the wavelengths of that light right along with it. So over billions and billions of years, that brilliant, hot light got stretched out so much that it cooled down, becoming the faint microwaves that we detect today.
Okay, so when we use our incredible telescopes to look at this light now, after all that time, what are we actually seeing?
I absolutely love this way of putting it. It really is like the universe's first selfie. The cosmic microwave background is a literal snapshot of the universe when it was just 380,000 years old. Think about that. It is the oldest photograph we will ever be able to take, showing us what everything looked like when it was just a baby.
Now, what's so fascinating about this baby picture is that it isn't perfectly smooth. If you look really, really closely, it has these tiny, almost imperceptible differences in temperature. And those tiny little fluctuations, they are the most important part of the whole story. The slightly hotter, denser spots you see, those are the siege of everything that exists today. These little spots had just a tiny bit more gravity, and over hundreds of millions of years, that tiny edge was enough to pull in more and more stuff, eventually building the first stars and galaxies. And the colder spots? Well, they became the vast, empty voids of space. So this isn't just a picture. It's literally the blueprint for our entire cosmos.
And by studying this incredible blueprint, scientists have unlocked some of the most fundamental secrets of our universe.
So, why is this ancient glow so important? Why do we care so much? What does it really tell us?
Well, pretty much everything. By analyzing the tiny patterns in the CMB, we figured out the exact age of the universe. That's where the 13.8 billion year number comes from. We learned its shape. It's almost perfectly flat, which is weird and cool. We can measure precisely how fast it's expanding. We even know its ingredients. Like a recipe, we know exactly how much normal matter, and dark energy make up the whole thing. Seriously, almost everything we know about cosmology is built on the foundation of studying this one single ancient light.
So the next time you look up at the night sky, just remember this. The darkness between the stars, it isn't really empty. It's glowing. It's filled with a message from the very dawn of creation, a constant, beautiful reminder of where we all came from.